Now, looking at the descending limb, we're going to draw another arrow, and we're going to label it as reabsorb. This descending limb is really big and very permeable to water. So we're going to reabsorb a whole bunch of water back into the blood system. That's what's happening there. Then we have the loop of Henle. We come over to this ascending limb, and we're going to do some more reabsorbing into the blood. But this one's not really permeable to water. So we're going to reabsorb, if you can see it, my pen's running out, got clay on it. Reabsorb salt. So, we always have said where sodium goes, water follows, but in this instance, this ascending loop isn't permeable to water, so we're just removing salt here. Okay, another little arrow, and this one's going down, and we're going to put an S, so we're going to secrete, and we're actually secreting. Well, no, it wouldn't go down. I'm sorry. Back that up. Let me get rid of that because that's an error. We would not draw it down, because if you're secreting, then it's going to go here. Okay, so we're going to secrete, and it's going to go back up into that tubule. So we're secreting from the blood into the tubule, and what we're secreting here from the blood to the tubule, or the P, is going to be potassium again. I'm going to secrete some more potassium here. And now, instead of bicarbonate, you're going to see hydrogen ions, so acids, will be regulated in this distal convoluted tubule. Up here, we're going to put an R for reabsorb into the blood, and we're going to reabsorb some more salt, and where sodium goes, water follows. So we're reabsorbing water as well. Salt and water. Okay, so now coming over here to this collecting duct, we're going to reabsorb lastly here, reabsorb. We're going to reabsorb some urea. That's the first time you've seen that, some of that waste product. We're going to reabsorb some urea, some more salt, and where sodium goes, water follows. So we'll have water there. Now the last thing is the end result, and we're going to put an E here for excrete. This is what we're actually going to exit out of the body. We're going to pee out, and you're going to pee out, majority of it will be water, but we'll have some potassium as well. So some water, some potassium, some salt again, some bicarb, so that base, and then the big end product that we filtered out early on is creatinine. So remember, we removed it here in the renal corpuscle, removed creatinine, and we never reabsorbed the R's. We never took it back into the blood anywhere through here. So you should see it out at the very end result. Creatinine is a good indicator of renal function. So on lab work, blood work, they'll look at those creatinine levels. Okay, lastly here, we talked about reabsorbing into the blood, secreting from the blood into the tubule. Now let's talk about two hormones quickly. The first one up here on the distal tubule, aldosterone. It's a steroid, aldosterone. So aldosterone, what it does is it causes these distal tubules, it causes them to go ahead and get rid of. So what we'll do is reabsorb sodium in this distal tubule, or in this capillaries on the distal end will reabsorb sodium, thus reabsorbing water and increasing blood pressure. So aldosterone is triggered by that renin-angiotensin-aldosterone system when blood